All right, ladies and gentlemen, thank you for continuing with my series. Welcome to lesson 1.1. We're going to start talking about basic components of Java and basic components of how computers work, just to give you a real quick overview of how all the stuff behind the scenes happens before we actually jump in. Okay? So what is Java? Java is an extremely popular object-oriented programming language that was originally developed by Sun Microsystems in the early 1990s. It's grown drastically since then. They're currently on version 8, and they're no longer owned by Sun Microsystems. Now they are owned by Oracle Corporation, which of course is the famous database company. And they were acquired by Oracle in 2010. That's just a fact. Don't really need to talk about that too much. I'm not going to go into history too much now. And like I said, they're currently on version 8. So, why learn Java? Learning Java makes it easier to learn other programming languages. Everything in Java carries over to C++, VB.NET, things like that, PHP, whatever language you want to talk about, it carries over. They all relate in one way or another. If you learn how to do something in Java, the syntax might be a little different in another programming language, but the concept is the same. Once you understand the concept, you'll know how to program. And it's not like, going from English to Japanese. It's like not even going from English to Spanish. It's like going from British English to American English. Like the wording's a little different, but the meaning is still the same, and you can tell what's going on in any programming language once you learn the basics of one, and Java is definitely a good starter one. It's extremely popular, used on billions of devices worldwide. It runs on any operating system, Linux, Mac, Windows, whatever you have. And that's because Java was developed this way back from the start. They knew that they wanted to create a programming language that would work across many different types of systems. So they have this write once, run anywhere slogan that they had. And that just means, you write the code once, you write it in Windows, it'll work on Mac, it'll work on Linux. And of course, Java is also the primary programming language used on Android devices, which is the most popular mobile operating system. And once you complete the series, we'll be able to talk a little bit more about developing apps for Android if that's something you're interested in. Alright, and finally, Java is an object-oriented programming language. And that means that we can think of things in terms of objects. So, for example, you could have an object that would be a person, and then you could have individual different types of persons that would inherit from that superclass person. So if we have a person up here, and then we have, say, a teacher and a student down here, we would be able to assign specific properties to the person class. So each person could have a name and a gender, for example. And then each student would also have a name and a gender, and each teacher would also have a name and a gender. But then we could assign specific properties for teachers. So teachers, for example, would have to have a salary. So we would give the teachers a salary, whereas the students don't need a salary, so they're separate things. The students, however, would need to have grades. So the student object could have grades, the teacher object could have salary, but they would both be persons, so they would inherit from that person class. And that means we don't have to write individual name and gender for each type of person, because we already did that in our person class. So certain properties of the superclass go down to the subclasses, and that's basically the general concept of object-oriented programming. We're not going to discuss object-oriented programming too much in the beginning of the series. We are going to learn how to use objects from the Java API, but we're not going to specifically be learning about how to create objects quite yet until later in the series, because I want to lay down the foundations first, alright? So you don't have to worry too much about OOP, object-oriented programming, yet. Okay, so we're going to start digging into this. I'm going to teach you about how computers work. And this is going to be a pretty simple overview. I'm not going to get into a ton of detail here. I have a computer out here in front of me, so I'm just going to go over the basic components of it. Let's take a look. Alright, so here we have an open computer. It's an old computer of mine, so I apologize, it's a little bit dusty. but concepts are the same regardless of what kind of computer you're looking at, whether it's a new one, an old one. The pieces are still the same. They just might look a little different, might be a little smaller, of course, in new computers. This guy here is about 10 years old. This is Dell XPS, and it actually ran great, so I highly recommend Dell XPS. Great system, and great. Overall, I really love this computer. So here we have the heatsink. That's not really very important, but you can see how massive this thing is. And the only job of this is to control the temperature of the CPU, the central processing unit. So this just cools the CPU down and keeps it at optimal temperatures for running. So the CPU gets extremely hot when it's running, and you can download apps and stuff to see what your actual CPU temperature is. Check that out. Here underneath that heatsink, we have the CPU. So let's pop that guy out here. And it's an old computer, so I don't really care about it, but don't go opening up your computer and looking at this stuff unless you know what you're doing. Doing this, I could just inadvertently be totally damaging the computer by doing this, so don't follow my example here. Anyway, so this little guy is the CPU. Very small, but it's the central processing unit, so this is actually what does all the calculations on the computer. The most important part of the computer is probably the CPU. It's like the brain of the machine. It does everything. And you can see this huge thing here, this tiny chip here. It's amazing how hot these things get. All right, so the next thing that we're going to take a look at is the memory. This is called RAM, random access memory, or primary memory. And what happens is this is where the computer stores data for processing with the CPU. It's random access memory because it can be accessed randomly. That's something we'll get into a bit more later, but just understand that RAM works very fast. This is fast memory, and we want it to be fast because we need it to be able to do things in the CPU. The CPU needs to do things. It needs to access memory. It needs to be able to go back and forth between these here. The data has to flow frequently. Otherwise, the computer will just be a slow piece of crap. So yeah, that is the main memory there. Now let me take a look here. If you take a look down here, actually, you can see I have hard drives there. So yes, here is a hard drive. 500 gigabytes. I didn't realize I still had this guy. Might come in use. Looks pretty good too. Anyway, so this is a hard drive. This would be a secondary memory. So the secondary memory is where all your documents, all your programs, all your files, that's where it all gets saved for long term. So this isn't actually what the CPU is reading directly. When you load a program on your computer, what happens is it's stored on the hard drive. So let's say you want to open Microsoft Word. Microsoft Word keeps all its program files on the hard drive. Then you go in, you use your mouse, you open Microsoft Word. What happens is the hard drive passes all the data that's needed for Microsoft Word. That goes into the random access memory. So it goes from the hard drive to the RAM. And now once the program's loaded into the RAM, the data can go and be processed and used by the CPU. So the CPU goes ahead, reads and writes from the RAM while the program's open, and then you save your file that you're editing, your Word document, that gets saved back onto the hard drive for later use. But anything that you actually have open on your computer is technically not on the hard drive. It's being held in the RAM. And that's why with games and stuff, you see long loading times. It's getting a lot faster with the newer computers and whatnot. But, you know, some games can be 20, 30 gigabytes, and that's all on here. And parts of that have to be loaded. It doesn't load it all at once, of course, but the important parts of that have to all be loaded into the RAM. So, you know, a game might have 3 or 4 gigabytes that need to be loaded into here before the CPU and the video card can even do anything. All right, so another example of a secondary storage device is a CD-ROM drive or DVD-ROM drive, and this can read and write information to a disk, of course. So in the same way that we store information on a hard drive for long-term use, we might also store and load information with a CD or a DVD in a CD-DVD ROM drive. So that is secondary memory there. Alright, and I'm sure you already know this stuff, but these are output devices. So something like a printer or a computer monitor in this case would be an output device. An input device would be like a keyboard or a computer mouse, so those would be considered input devices. Anything that you use to give information to the computer is an input device, and anything that displays or prints out information is an output device. So speakers would be considered an output device. The last thing I wanted to talk about was the operating system. Now, the operating system is a key component of how computers work that I didn't really include with the hardware because it's technically not a piece of hardware, it's a piece of software. But the operating system is the most important piece of software that runs on your computer. It lets you open programs, manage the file system, and do things like that. Examples of operating systems are, of course, Mac, Windows, Linux, Unix, anything like that, iOS even, Android, whatever, what have you. Alright? So that's enough boring nonsense about how computers work. Fun stuff. Alright, so CPUs, didn't escape yet, interpret machine code, and this is the binary code represented in ones and zeros, which provides instructions to the CPU. So it's incredibly hard to program in machine code. I don't know if you would particularly like that very much. 1001, yeah. No one would understand it, and it would just be crazy. But there are actually people who can do that. It's incredible. So people didn't have to develop in 1001, binary. They created assembly languages, so people started getting smart about how computers worked. And assembly languages are low-level programming languages which allow programmers to write machine code using English abbreviations rather than having to write the actual machine code. And a compiler, that's the software that reduces the code from a higher-level language to a lower-level language. So the piece of software which turns the assembly language into machine code would be considered a compiler. So anything that does that is a compiler. And finally, we have high-level programming languages. And that is things like Java, C++. Those are all high-level programming languages. And they use natural language elements to make it easier to program. They also include large libraries of functions, or in Java's case, methods, which can be accessed by programmers to speed up programming. So instead of having to write everything yourself, it's already available for you in a library. We'll get into that a lot later. Another advantage of object-oriented programming, we have these huge libraries of objects that we can use, so we don't have to create them ourselves. For example, it would take hours to even days to create a basic Windows application with a button and a text box if you were to do it all yourself. But Java provides objects, button objects, text box objects, and then you can just add these to your program. You don't have to go and create these things yourself, which greatly speeds up programming time. Alright, so Java from source code to execution. So this kind of goes hand in hand with the just-in-time compiling type thing that I talked about. Write once, run anywhere. This is how Java works and how it achieves that. How it achieves that you can write a program on Windows and it'll run on Mac. So we have our source code, myprogram.java. So that would be our program file with all the source code in it, and all of our code goes in the source code, of course. Then that information gets passed to the Java compiler. The Java compiler doesn't compile the code directly into machine code or anything like that. What it does is it compiles it into bytecode. And bytecode is kind of like in between, not really a high-level programming language, but it's a different kind of code that Java can interpret. So it goes from our source code into this bytecode, and then we use what's known as a Java virtual machine. And the Java Virtual Machine is a piece of software which runs on any device that can use Java. So for example, you would have a Java Virtual Machine for Mac, a Java Virtual Machine for Windows, a Java Virtual Machine for Linux. And then with that, once it's in bytecode, the Java Virtual Machine actually takes that bytecode and then that runs it for the specific operating system. So that way you write it once as your Java file, compiles it into bytecode, and then the Java Virtual Machine looks at that bytecode and it uses that to run the program on whatever host operating system that you're using. So that's what makes it work. Tools needed to program. We're going to need to know how to get and install the Java Development Kit, also known as the JDK. That is the set of developer tools that we'll need, the Java compiler, things like that we'll be using to create our Java program. So we're definitely going to have to get that. The other tool we're going to use is Eclipse, and Eclipse is an integrated development environment, and specifically it's not specifically made for Java. It does a lot of different programming languages, but it works really well for Java. It's definitely one of the most popular Java development environments. So this is going to be our text editor. So this is our Microsoft Word for Java, basically. And it allows us to simply, once we have this stuff installed, we write our code in Eclipse, we click the Run button, and it runs our program for us. Really awesome.
Alright, so this concludes Lesson 1.1. Please continue to video 1.1b to learn how to set up Java and Eclipse. Alternatively, download and install these programs yourself. The links are in the description, it's not that hard. And continue on to Lesson 1.2.